everybody hear me okay? Yes. Everyone's good? All right. So welcome once again to Hoover Dam. This is a map of the Hoover Dam site. And this is where we are. We are standing inside of a diversion tunnel. So when they began to build the dam, they needed to find a way to move the river from the construction site, and they did that by building 4 diversion tunnels. There's 2 on the Arizona side and 2 on the Nevada side. They're 50 feet in diameter, about 3/4 of a mile long, and it took them almost 2 years to completely blast out all 4 tunnels. Once those tunnels were finished, they had to figure out how they were going to push the river into the tunnels, and they did that by building coffer dams. A coffer dam is a temporary earthen dam, and it creates a dry area where they could do construction. So they built bridges across the river, and about every 15 seconds, a truck would drive across and dump all that debris from blasting out the tunnels into the river. And that's how they started to build up these 2 coffer dams. So one is built upstream. This one pushes the river into the tunnels, and the other is built downstream. This one keeps the river from flowing back into the construction site. So once those coffer dams were finished, they drained the site and they removed 135 feet of loose rock debris and silt to get down to the bedrock, which is the dam's foundation. That took about 7 months. June 6, 1933, they were ready to begin building the dam. They had buckets carrying 8 cubic yards of concrete, which is 16 tons. Those were delivered every 78 seconds. They did it 24 hours a day, 7 days a week for 2 years. Once they were finished building the dam, then they were ready to begin filling up the lake. They did that by closing off 3 of the diversion tunnels, by lowering heavy steel gates. They did leave one tunnel open, that way the river could continue to flow back downstream. So once the water was high enough, they did close off that last diversion tunnel. They blasted out the lower coffer dam, that way the river moves more freely as it's traveling downstream. But the upper coffer dam, it still remains underwater today. It took a total of 6.5 years to completely fill up the lake. So how do we get water from one side of the dam to the other? Intake towers, and there are 4, 2 on the Arizona side and 2 on the Nevada side. They're 395 feet tall, and they sit up on 250-foot rock ledges. So the water flows down through them into 30-foot diameter penstock pipes like this one that you can see out the window. So you may feel the floor vibrating beneath your feet, and that is up to 96,000 gallons of water per second flowing through the pipe. That would be enough water to fill an Olympic-sized swimming pool in just 7 seconds. Then the water flows down into smaller 13-foot diameter pipes that leads to the generators spinning the turbines, and then it flows back down the river. Last thing I'm going to tell you about are the spillways, and they're on either side of the dam. There's one on the Arizona side, one on the Nevada side. And they were built to keep floodwaters from going over the top of the dam. We've used them twice. Once in 1941 for testing. So when they first filled up the lake, they overfilled it on purpose. Thank goodness they worked, because in 1983, we did have a flood. There was a heavy snowmelt up in the Rocky Mountains. That's where all our water comes from, and all the conditions were just right that year. So here's a picture from the flood of 1983. This is the dam right back there. The water ended up cresting within 7 feet from the top of the dam. That is way too close. When this flood was occurring, water was going over the spillways for 63 days in a row. That's about the equivalent of 2 Niagara Falls every single day. So the water goes into the spillways, through the tunnels, around the dam, and then safely back into the river. All right, the next stop on our tour is going to be the Nevada wing of the power plant. So I'm going to go out first, and you guys are going to follow me back to the elevator, okay?